Star Trek, a beacon of science fiction, invites us to explore a future where technology redefines the limits of what is possible, and where science, both real and imagined, is the engine of adventure. Let's start with travel at speeds greater than the speed of light, the famous warp drive. Einstein's theory of relativity states that nothing with mass can reach the speed of light, but Star Trek gets around this limitation with the idea of bending spacetime, compressing it in front of the ship and expanding it behind, thus creating a bubble of space that allows travel at unthinkable speeds. Although this idea is theoretical and we do not yet understand how to manipulate spacetime in this way, theoretical physics has explored concepts such as the Alcubierre metric, which suggests that it could be possible. Teleporters, another cornerstone of the saga, pose an even greater challenge. The idea of dematerializing an object, converting it into information, and then reconstructing it somewhere else is, for now, a fantasy. In quantum mechanics, there is the concept of quantum entanglement, where two particles can be linked in such a way that the state of one instantly influences the state of the other, regardless of the distance. However, teleportation in Star Trek goes much further, involving the transfer of information from a macroscopic object, which is a problem that current physics does not know how to address. Energy shields, which protect ships from attack, are inspired by the magnetic fields that protect Earth from solar particles. However, in Star Trek, these fields are much more powerful and capable of deflecting energy, laser beams, and projectiles. Plasma physics, which studies the behavior of ionized gases, could provide a basis for understanding how to generate such intense energy fields, but we are still far from achieving something like that. Wormholes, shortcuts in spacetime, are another fascinating idea that emerges from Einstein's general relativity. The theory predicts that tunnels connecting different points in the universe could exist, but we have no evidence of their existence and we don't know how to traverse them, as it is thought that they would require an exotic form of matter with anti-gravitational properties. Food replication, a technology that eliminates the need to grow or process food, speaks to the manipulation of matter at the atomic level. Nanotechnology, which studies the manipulation of matter at the nanoscale, could hold the key to this type of technology, but we are still far from being able to assemble complex molecules like food at will. Exploring planets with varied atmospheres and conditions shows us the diversity that could exist in the cosmos, although sometimes with altered laws of physics. Astrobiology, which studies the possibility of life on other planets, is a real science that seeks to understand the limits of life and the environments where it might thrive. Instant communication over large distances, although in practice limited by the speed of light, speaks to the possibility of quantum entanglement, as we have already mentioned. Quantum physics is a very strange and counterintuitive theory, but it best describes the behavior of matter at the subatomic level. And finally, time travel, a recurring theme in Star Trek, leads us to explore the paradoxes posed by theoretical physics. Einstein's theory of general relativity allows for the possibility of time travel, but the paradoxes that arise, such as the grandfather paradox, make it a highly controversial topic and many physicists believe it is impossible. Star Trek, at its core, is a reflection of our curiosity about the unknown and our aspiration to push the boundaries of what is possible. It shows us a future where science is the key to exploring the universe and where technology allows us to achieve goals that seem unattainable today. Although many of the ideas in Star Trek are science fiction, they also inspire us to continue investigating and dream of a better future.